In sketching algebraic and transcendental functions, we need to learn maxima and minima, first derivative test, second derivative test, concavity and inflection points, and asymptotes. The maxima and minima is a function known collectively as extrema, which is called plural of extremum, are the largest and smallest value of the function, either within a given range, which is called local or relative extrema, or on the entire domain of a function, which is called global or absolute extrema. So here are the examples of maxima and minima graph points. A local maximum point on a function is a point xy on the graph of the function whose y-coordinate is larger than all other y-coordinates on the graph at points close to x and y, while a local minimum point if it has locally the smallest y-coordinate. And a local extremum is either a local minimum or a local maximum. As you can see on the graph, that's what you call concave up, which means positive to negative is increasing. Next is concave down. As you can see in the graph, it goes down, which means negative to positive. How about inflection points? Inflection points is the concavity changes from up to down or down to up. That's what you call inflection point.
Example number 1. Y equals to x cubed minus 6x squared plus 12x. So to proceed, the first thing to do is to derive the function. So the derivative of x cubed is 3x squared, and the derivative of negative 6x squared is negative 12x. And the derivative of 12x is 12. As we get the result, we must simplify it as much as possible so that we will not be encounter difficulties. So what we'll do is we will cancel out. Since as you can see, these numbers are divisible by 3, so that we must cancel out by using 1/3 and write the equation. 3x squared minus 12x plus 12. So cancel, cancel, cancel. What remain is x squared. 3 divided by 12 is 4, negative 4x, and same here, 4. So the answer is x squared minus 4x plus 4. What would happen next? As I've said earlier, we must simplify it as much as possible. So this thing, it can be still simplified, and the simplified of this function or this expression is x minus 2 squared. So that is the simplified form. What will happen is we must equate it to 0. And next, how could we find our x? We must think of the value that can result to 0 in order to find our x. So that the x will be 2. Am I right? Since if you put x 2 minus 2 equals to 0 squared, the result is 0. So that's why we should use 2 as our x to result as a 0. So we already get our x, which is equals to 2. What about our y? So to get the y of the function is y equals, we should replace the value of x of our x, or we should input the value of our x on the original equation. So 2 cubed minus 6 times 2 squared plus 12 times 2, which is referred to our x's. So as we calculate it, and the result is equals to 8. So our y is equals to 8. So our y is equals to 8. So the next step is we will find the maximum and minimum of the equation. So for us to be easy in our finding our maximum and minimum, is what we will do is we will draw a line. Since our x is equal to 2, we will put the middle of the 2. So this indicates that x is greater than 2 and x is less than 2. So we will choose a value that is greater than 2 and less than 2. So it is, for greater than 2 it is 3, and for less than 2 is 1. So we will plot the values. X is greater than 2 at x equals to 1. What is our y? To determine our maximum minimum. So as we derived earlier, our derivative of this one is 3. Okay, what would we do next is to determine the maximum and minimum. But as I've learned, is not all functions have maximum and minimum. So let's try to find out if this function have maximum and minimum. So this is the derivative of our function and our x. So if what we'll do, for that we could not encounter difficulties in finding or determining the maximum and minimum of the function, is we will draw our line to indicate n2 as our x, which is in the middle. This means that x is not less than 2 and x is not greater than 2. So we must think of the value that is not less than and greater than 2. So those are x equals to 1 and x equals to 3, because 2 is greater than 3 and 2 is less than 1. So to determine our derivative, there are x's, right? We must input each of the x number 1 and x2. So x squared, x is less than 2 at x equals to 1. So 3x squared minus 12x plus 12. So input the values, which is 1 minus 12, 1 plus 12. Always put in your mind that we use to input the value is the derivative of our function. We calculate it. The result is 3. The result of x less than 2 at y equals to 3, which we use x equals 1, the result of it is y equals to 3. So what about the greater than 2? So we think of 3, right? So x equals to 3. So same what you do last x equals to 3. So again, use the first derivative and then input the values, which is 3 minus 12 times 3 plus 12, and then calculate. So we calculate, the answer is 3. So we calculate it and the result is 3. It should be right like this. X less than 2 at 1, 3. This is our x and our y, which we solved earlier. As you can see that. And then x is greater than 2 at 3, which is our x, which is our x, and our y is 3. So it means there are no maximum minimum because they are both increasing. In our mind that positive to negative is minimum, and negative to positive is maximum. But not all functions have this too. But before graphing, we need to figure out our x-intercept and y-intercept. So our x-intercept, y equals 0, x cubed minus 6x squared plus 12x we need to equate it to 0 and then factor it out. So when we factor it, this will be the result. 6x plus 12. Why? X times x squared is x cubed. X times 6x is 6x squared, and 12 times x is 12x. So what we'll do is x equals to 0 is the result of our x-intercept. Why? X equals 3 plus 2 square root of 3, and x equals 3 minus 2 square root of 3. And that makes the result why our x-intercept is equals to 0. Our y-intercept, we need to equate 0 into the excess to get our y-intercept. 0 cubed minus 6, 0 plus 12, 0. So the result is y equals to 0 as our y-intercept. So our x-intercept is equal to 0, and y-intercept is equal to 0. How to graph our function? So this is our y and this is our x. 0, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. 7, 8. So, how to graph? Our x and y intercept is 0. So our graph looks like this. 0, 0, 0, x and y. And this one is 2 and 8, which we solved earlier, which is our inflection points. Take note, inflection points and critical points are the same. 0 and 0 is our x and y intercept, which they intercept. So this one is downwards and this one is upwards. As you can see in the graph, they are increasing.
So, tonight, we have another example about algebraic curves. So, I have this equation, 6x over x minus 3 to the power of 2/3. But this equation is already derived. So first, what we're going to do is to divide it into two parts. The first part is the 6x, and the second part is the x minus 3 to the power of 2/3. So the third thing we're going to do is we will going to find any value that can equate it to 0. For example, 6x. Our value we choose is 0. So 6 times 0 equals 0. And then x minus 3. When x equals to 3, 3 minus 3 equals to 0. So that will give us a 0. The second, we're going to make this line, number line. We'll go in this number line, we will choose any number that is less than 0, greater than 0, less than 3, and greater than 3. So first, the negative 1. The negative 1, we will substitute it to the all x's in the derived equation. So here's 6 times negative 1 over negative 1 minus 3 to the power of 2/3. If the answer is lower than the x, that means it is decreasing, so it is minus. The second one is x equals to 1. X equals to 1. 6 times 1 over 1 minus 3 to the power of 2/3. So the answer is 3.77. It is go upward because it is increasing, because the answer is larger than x. That's why it is plus. The same here. The answer is 24. That's why it is plus. So here are minima. The x equals to 0 is our minima. So if we were going to sketch this minus, it said minus, that's why it is going down to the 0, and from 0 it's going up because it's plus. So done.
Now we're going to solve this function. Y equals negative x cubed plus 21x plus 3. Now we're going to derive this function. Y prime equals 21x squared plus 21. Next is we're going to equate to 0. 0 equals negative 21x squared plus 21. The next is we're going to solve for x. 21x squared equals to 21. The next is now we're going to substitute positive 1. Y equals negative 7 times positive 1 cubed plus 21 times positive 1 plus 3. And the result is y equals 17. Next is we're going to substitute negative 1. Y equals negative 7 times negative 1 cubed plus 21 times negative 1 plus 3. And the result is y equals 11. So x is negative 2, the result is negative 63. So it is decreasing. Next is when x is equal to 0, the result is 21. So it is increasing. Next is if x is positive 2, the result is negative 63. So it is decreasing. Now we're going to find the x-intercepts. First, we're going to substitute the original equation. Negative 7, 21, 3. First, that equals 3.136. The second is negative 0.1366. And the third is 0. For y-intercepts, we're going to substitute all 0 to all x's. In the maximum, it is positive to negative, and to the minimum, it is negative to positive. And for our maximum, it is 1 and 17. And for our minimum, it is negative 1 and 11. As you can see in the graph, 1 and 17 is going to negative, and our minimum is negative 1 and 11, or our minimum is going to positive.
So now, we are going to solve and sketch the function x squared times 1 minus x. But first, we need to derive the function in order to get the critical points. In deriving this type of function, we are going to use the product rule, which is f ds plus s df, which f is equal to x squared and s is equal to 1 minus x. Then, we derive f and s to get df is equal to 2x and ds is equal to negative 1. After having all the values for the product rule, we need to input it to get y prime is equal to x squared times negative 1 plus 1 minus x times 2x. Then, we multiply x squared and negative 1 and 1 minus x and 2x to get negative x squared plus 2x minus 2x squared. After that, we equate it to 0 and combine like terms, which will get 0 is equal to 2x minus 3x squared. After that, we factor it out to get 0 is equal to x times 2 minus 3x, which x is equal to 0 and x is equal to 2/3 or 0.667. After that, we substitute 0 and 2/3 to the original equation so that we will get the y. So, 0 squared times 1 minus 0 and 2/3 squared times 1 minus 2/3 is equal to y is equal to 0 and 4 over 27 or 0.148. So 0, 0 and 2/3 and 4/27 are our critical points. So after solving the critical points, we are going to derive the first derivative in order to get the point of inflection. So y prime is equal to 2x minus 3x squared is equal to y double prime is equal to 2 minus 6x. Then we will equate it to 0, which will give us 0 is equal to 2 minus 6x. After that, we will transpose negative 6x, which will give us 6x is equal to 2 over 6 or 1/3. So same with what we did earlier, we are going to substitute 1/3 to the original equation, which is 1/3 squared times 1 minus 1/3 is equal to 2 over 27 or 0.074. So 1/3 and 2 over 27 is our point of inflection. So after getting our critical points and our point of inflection, we are going to input x squared times 1 minus x to our calculator, starting from negative 2 ending to 2. Then after we input the values in our calculator, we are now going to put the points in our graph. So negative 2 is equal to negative 2, 12, and negative 1 is equal to negative 1, 2. So 0, 0, our first critical point, and 1/3, 227, which is our point of inflection, and our other critical point, which is 2/3 and 427, then 1, 0, and 2, negative 4. So after we put the points, we are now going to sketch the graph, and our graph will look like this. So we can see that this is how our graph looks like. This is the point of inflection, our critical points, negative 2 to 2, and 2/3, 427 as our local maximum.
Video we're going to learn about the sketching of transcendental functions. So we have here a graph. So we know that these are the values of the sine and cosine of some common angles. So we know that there is 0, pi over 2, pi, 3 pi over 2, and 2 pi. In a manner, we can also sketch the graph of the function y is equal to sine x. So it goes like this. The sine of 0 is 0. The sine of pi over 2 is equal to 1. The sine of pi is 0. The sine of 3 pi over 2 is equal to negative 1. And the sine of 2 pi is equal to 0. So similar as in the inverse in the negative side, we can denote that the sine of negative pi over 2 is equal to negative 1, and the sine of negative pi is equal to 0. Therefore, we will have a graph that looks like this. So let us also have an example of the function y is equal to sine x. So sine of 0 is equal to 0. The sine of pi over 2 is equal to positive 1. The sine of pi is equal to 0. The sine of 3 pi over 2 is equal to negative 1. And the sine of 2 pi is equal to 0. Same as in the negative side, which is the negative pi over 2. Its sign will be negative 1. And finally, the sine of pi is equal, negative pi rather, is 0. So if we're going to sketch its graph, it will be going to look like this. So this function has an amplitude of 1 because the graph goes 1 unit up and 1 unit down. So it goes 1 unit up and 1 unit down from the midline of the graph. So this function has a period of 2 pi because the sine wave repeats every 2 pi units. We're going to have a function like this. Y is equal to 3 sine x. So what we're going to do is just change the amplitude. So instead of going up to positive 1 and going down to negative 1, it will now go up to positive 3 since we have a 3 here, and going down to negative 3. So as usual, the sine of 0 is 0. The sine of pi over 2 is equal to 3. So as we can see, we will now an amplitude of 3. The sine of pi is equal to 0. the sine of 3 pi over 2 is equal to negative 3. And finally, the sine of 2 pi is equal to 0. So what about the negative side? So the sine of negative pi over 2 will be negative 3. The sine of negative pi is equal to 0. The sine of negative 3 pi over 2 will be 3. And finally, the sine of negative 2 pi is equal to 0. So if we're going to connect and sketch its graph, it will look like this. So the form of, or the shape, or the form of the graph is just the same. It's just that we changed the amplitude from earlier. As we can see, the amplitude is 1. Since it's 1 here, it's understandable that it's 1. And compared to this, we now have a 3. So the amplitude is 3. So as I've said, so the amplitude has changed from 1 in the first graph to 3 in the second. Just as the multiplier in front of the sign changed from 1 to 3. So this relationship is always true. Whatever number a is multiplied on the trigonometric function gives you the amplitude. That is the tallness or shortness of the graph. So in this case, the amplitude number was 3. I'm going to have an example here of how to graph the function y is equal to cos x. So we know that the cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi is equal to negative 1. The cosine of 3 pi over 2 is 0. And the cosine of 2 pi is equal to 1. Thus, we will have a graph that looks like this. What if we will have a function that goes like this? So y is equal to negative 5 cos 4x minus pi over 3 plus 8. So what we're going to do first is input this in our calculator. So first we are going to make sure that our calculator is set in radian mode. So how do we do that? So let's shift mode, then select number 4, so to turn our calculator into radian mode. So that's it. Then since we are going to graph this function, so we are going to mode 7 for the table. So there. So we're going to input negative 5 cos 4 alpha x minus shift pi over 3 plus 8 equals. So we are going to start at 0 and at 2 pi, and let's have a step of pi over 6. So, and then we got the values. So it says in our calculator that this is our table of values. So if we will start at 0, so our point will be at 5.5. So we got it here. At 0.5235, our point is still at 5.5. Then at 1.0.0471, so it must be here. Our y or f of x is at 13. So 13. At 1.5707, so it must be here in the middle of 1 and 2. Our point is at 5.5. At 2.0943, our point is still at 5.5. 2.6179, it's again on 13. At 3.1415, our point is again on 5.5. At 3.6651, again it's on 5. So notice that our points looks like repetitive. So as we have discussed earlier, that if we will try to connect these dots or points, so it will have a graph like a repetitive waves. So since we have discussed that this will be the form of the graph of sine and cos, so if we will try to connect this, it will look like this. So let's recall that if we have this, so let's expect that our graph will shift to this number. So since we have plus 8, so expected that our graph will shift 8 units up. So that's why 5, so here's our 5. 5 plus 8 is 13. Because even though it's negative 5, we have to look for its absolute value. So the absolute value of A, this is our A, this is our D. So expected that our maximum value rather is at 13. So notice the graph is in here. So if we will connect this, so we will connect that, we will have the maximum value of 13. So since it's a good post. Kalimot na ko sa akong isod. Before we forget, so since this is 8 and we need to have a symmetrical graph, so expected that 8 is the center. So and 5, so if we will count 5 upwards, 1, 2, 3, 4, 5, that's the 13. And if we will count 1, 2, 3, 4, 5, so we arrive at 3. So this is what we call our minimum value or minima. So we will trace this like here. So if we will try to complete the graph, so it will look like this. So we now have the graph for this function.